gonna see if this little stylus works that Miss OD got us on. Little fancy stylus.
It also has like a. I'm used to writing with my finger, but
I think it has a. I think there's a thinner one.
I don't know. I'll try it. Okay.
So questions?
On your summer work, just call out a number.
Yeah, 46.
Oh, 46. I'm sorry, I'm doing the wrong. Let me go ahead and do 47 on here, and then I'll go back and do 46. So this is 47. Okay. So this will happen to you. It happens to me still. It certainly happened to me when I'm going to take this on and off. I'm going to get hot and cold. It certainly happened to me early on in calculus. But what you learn to do is what I said. You open a door, walk through it, open another door, walk through it, and get started on the problem. And it comes way sharper into focus. If it doesn't fully focus, at least it gives me a place to help you instead of I don't know what to do. So I saw the word parallel too, so I thought I could do that based on like previous math experience. Everybody can rearrange this or however you find your slope. So you'll find that I go super fast in here. And so you'll know the first few days if you're in the right place. I suspect that you are all in the right place, but you'll know, okay, because I go super fast. So your slope is 12, okay? You can always stop me and ask me why though, or come by and go, I'm so embarrassed I don't know how to find the slope. I can't tell you how many gaps there were in my learning. I could do calculus, but sometimes the algebra would trip me up because I didn't have a very good algebra teacher or something like that, okay? Or because I wasn't listening to my good algebra teacher. It's probably more like it. But you can't imagine the, in quote, embarrassing questions I had to ask my friends because I was too embarrassed to ask my teacher. Like, I really don't know what that means. So, but you're smart enough just to pick it up and keep on going with it. So don't hesitate to ask me that. I'm not going to laugh at you. All right, so the slope is 12. The slope of this line is 12. And now I've got to find the equation of the tangent line. Well, to find the equation of a line, I need its slope. So let me show you what's happening here. Morgan this morning, I think it was you that said, well, you know, would it help to graph it? Or was that something else? Celine. Okay. So y equals x cubed looks like this. By the way, for ourselves, a lot of times I'll do really rough sketches of graphs, but even if I or the AP program says sketch a graph, we don't really mean sketch, we mean draw. So always mark off your units, so just follow my lead. Right now I'm just sketching real loosely just to give you an idea of what happens. Hopefully you've watched some of the videos to help you. And so what happens is this does not have a slope. Doesn't it have many slopes? Doesn't it have many rates of change? A slope is a rate of change, and the equation of the tangent line tells you what's happening very local. So there's really no reason for me to draw this big old line right there other than it helps you see the growth right at that moment. As soon as the moment changes, I get a new slope, don't I? So it slopes, and the derivative, small wonder, please ask me the ins and outs and whys because I love all of that. It's no wonder that the derivative actually finds you all the slopes because that's what it's based on. I kind of went over that maybe a little bit before Frost Valley. I can't remember what all we did that 45 minutes. But anyway, you're doing a difference quotient. You're saying y minus y over x minus x. You're saying that f of x plus h minus f of x is like y2 minus y1 over x2 minus x1. But they're very far apart. And what you're doing with the limit is you're moving the points closer together. How close can you get 2 points? Infinitely close, okay? So can I tell what's going on better if I'm right here rather than if I'm right here? Yes. If I look at these 2 points, probably not going to get a good idea of what's going on at this one or at this one, am I? Y'all see what I mean? But what if I could slide this point, see if I can grab it. I had it. Oh, wait. You get the idea. If I could slide that point closer and closer and closer and closer and closer, wouldn't the slope start to all of a sudden show me what's going on at that point right there at that moment in time? So it's a miracle. Like the limit turns 2 points into 1 point. It just slams the two together because you can get infinitely close. So I think that was a lot of information. So back to what we're doing here. We have y equals x cubed. Okay, and it's telling us that somewhere on here there's an equation of a tangent line that's parallel to this line. This line, when you rearranged it, the y-intercept, I believe, was 10. And we know this line's slope is 12. So we've got a line that looks a lot like this. And do you see somewhere on here the growth rate actually does achieve that? It looks like to me it might be 2 places. Okay? All right, so that's what's happening. It's all about the same slope. Later on, it'll be sort of like the mean value theorem that I teach you. All right, so anyway, what I'm going to do is now I'm going to say on this one, it didn't really tell you which one to use, but you're still kind of in the, you're in the f of x minus f of c over x minus c. That right there is what I call the crummy slope. That's a Miss Lazardi word. You're not going to find that in a math book. It is really crummy. I mean, it's not going to tell you what's going on somewhere. You could be very far apart. Once you put the limit on it, though, I'll lag it behind. Once you put the limit on it, as x approaches c, then all of a sudden it comes what we label the derivative at the point c. Alright, so x and c are far apart, but you're moving x closer and closer to c. Say, what's going on over there? Okay? So that's the derivative. So now I need the derivative. That's the definition of derivative. This is really called the alternate definition of derivative. The main one is f of x plus h minus f of x over h. And take the limit as h approaches 0. Did I talk about the difference in those a little bit the other day? Okay, I can't remember. Let me take another slide real quickly because derivatives and limits are so important. There's a few different things I could do to find out what's going on at C or A. We use C's and A's kind of interchangeably. And if this is X. So I have these 2 points, f of X and f of C. If I wrote the equation and I counted on that slope, you can see it gives me a crummy representation of what's happening at those points. All right, but I'm still going to have to find the slope. And so I'm going to say f of x minus f of c over x minus c. So I'm finding the slope between these 2 points, pure and simple. But then when I take the limit, as x approaches c, I'm not going to try to drag that again, but x is going to move closer and closer and closer and closer. And you can see that the closer I get, the more it tells me what's going on at C. So that's one definition of derivative, this right here. Okay, so x is getting closer to C. Another definition of derivative, we'll see if we can put on Louis' face, is I have an x, and I have h is the distance, and this is x plus h. So for instance, if x is 1 and h is 4, wouldn't that be 5? Are y'all with me there? This is really the fundamental definition of derivative right here. All right, so if I have a graph, and this is f of x plus h, and this is f of x, again, crummy representation of what's going on at either point, okay? But the gap between them now is h. It might be 75, it might be 2 units. We don't know what the gap is, but we have to create a gap because we have to to start off like normal people who don't have magic like us. We have to start off like normal people and find the slope. Okay, we have to go, this happened and this happened. What's my difference? And so I'm going to have f of x plus h minus f of x over h. And where did this h come from? Who can tell me where? Why is that just an h on the bottom? What is the difference quotient?
It's x to the x minus h.
It's the difference in my x's. And then somebody's already said x plus h minus x. Top the y minus y over x minus x. If you subtract these two coordinates right here, x plus h minus x, you get the gap between them. So this is x plus h minus x. But all that's left standing is h. Now what do you want to do to make this point go over here? You want that gap to close. So do you see the difference in this and this? This is two distinct points and x is moving closer to c. This is actually two distinct points, but I have a different notation where h is the gap between them. Notice nobody ever named the gap between these. Okay? This is really your definition of derivative right here, and that's called the alternate. You see it with c's, sometimes you see it with a's. We use a lot of c's and a's in calculus. X's and y's are usually, they're variables, not usually, they are variables. A's and c's are really usually reserved for constants. It just means we don't know what they are yet. Okay? Like for instance, if I was doing some sort of formula with your body mass index, you all have one. I don't know what it is. I don't know what mine is. But if I needed the BMI in the formula and then like put a bunch of variables in there, you see the body mass index would be a constant for Caitlin. It'd be a constant for Emma. It'd be a constant for Anna, and then they'd use the formula. Okay? A's and C's we use a lot for things that are going to be a constant. We just know what they are yet. There's one more that I thought I had done and I must not have. And I'll show you how I saw it on the AP one time. If I have a graph, and this is x, and I decide to move h in this direction, then this is x plus h. And if I move h in this direction, what is this? Those are supposed to be little dots. If I move h in this direction, what is this right here? X minus h. So here's your graph. Here's f of x plus h. Here's f of x minus h. When I do the difference quotient and say y minus y over x, I'll do it in just a minute, but before I do it, does anybody know what's going to be on the bottom? Y minus y, the difference between my y's, what's going to be on the bottom here? Sophia? 2h, okay? Because how far apart are these? What is the difference between this point and this point? H here and h there, you went the two h's that way. So if I say f of x plus h, if I say on the bottom, x plus h minus x minus h, if you think about that algebraically, your x's will cancel. And when you say minus that h, won't it really give you another positive one? All right, but logically it gives me 2h. And take the limit, and we still want h to approach 0, okay? We still want to bring it in. Now, look how beautiful that is. Do you see the slope of the tangent line right here would be about like this at x? If I'm on either side of it, do you see that could give me a really good idea of what's happening if I go on either side of it and slice through it? So that also works. The reason that I wanted to do all of this is I'll show you one thing I saw on the AP one time, and one of those dreaded, I don't like them on the SATs, where it's 1 only, 1 and 2, 1 and 3.
Oh, I hate those.
Yeah. So I hate it only a little bit less than I hate the which one is not something that I just can't do that. It's like it. I don't like it. Anyway, they had this. You may see it on your first test. A lot of things I teach, you also see them on tests because they're problems that I like. All of your tests, most of your worksheets, most of your quizzes, most everything that you do for me, but you'll do homework in the book, but everything that I give you is almost 100%, but not quite, old AP problems. So you're constantly reviewing, you're constantly used to the format, you don't get to the test in May and go, what in the world is this? It looks so different. It will look like what you're used to. So, anyway, one year they had like Roman numeral 1, the limit of f of x minus f of a over x minus a as x approaches 0. Number 2, the limit of f of x plus h minus f of x over h, sorry it's really ugly, as h approaches 0. Number 3, in some years I actually really don't even go through that other one, f of x plus h minus f of x minus h over 2h. I never saw the breakdown of the answers to this question. But I bet they got a wild variety of stuff from definition of derivative. The first one looks kind of right, doesn't it? What's wrong with the first one? I bet a bunch of people jumped on it because it just looks like what they saw in class. Is there any reason in that case for x to go to 0? I don't know where x is, but I don't need it to go to 0 unless a is. I mean, that didn't make any sense, okay? This one's good to go if it's just very classic. And the years that, for some reason, I don't think to go this way and show it, you know, somebody intuitively should know that's true, but they haven't seen it from their teacher, so maybe they didn't pick it. But that doesn't matter. We expect you to be super smart because you're in here. And you see how that should make sense to you? Pause and look at it and go, wait, that one makes sense too. Somebody's added age and subtracted age, so now the gap is 2age, and I do want to close that gap. So do you see it was 2 and 3? Okay. So anyway, let's go back to 47. And I did that part. That just threw in a lot of teaching from what I needed to do anyway. So the slope is 12. So now I'm gonna do f of x minus f of c. And so I'm gonna say f of x minus f of c over x minus c. I'm gonna take the limit as x approaches c. And I'm going to set it equal to 12. Does everybody understand what I'm doing? I'm forcing this to happen. So you can take notes or copy it later, you know, because I've already looked at all your work. Some of you are probably going to need to change some things here, I'm guessing. Okay? Caroline, I'll come to you in just a minute. But y'all see, from now on, know that this is a slope and this is a slope. And know what parallel is all about? It's got to equal that, okay? Caroline?
I was just wondering, are you recording?
I hope so. Yeah, that little dot's on it. But you need to always ask me. So check and see. And hopefully the sound's working. I didn't do a trial in here. All right, so the limit is x approaches c. All right, now you've got to factor x cubed minus c cubed. Okay? You've got to factor x cubed minus c cubed. And a lot of you forget how to factor a cube. I go over it again in pre-cal. I don't know if you did with your pre-cal teacher, and mine may not remember it either. All right, so it's that one with 2 little things and 3 things. It's like got a small parentheses and a big parentheses. The way that I taught it is square the front, put it in the front, square the back, put it in the back, stick them together, put it in the middle. I'll show you what I mean by that. Square the front, put it in the front. Square the back, put it in the back. Stick them together, multiply them together, and put it in the middle. What I mean by that is what is being cubed right here? What is being cubed right here? X and a C? All right, so this is going to be an X, and this is going to be a C. Worry about the signs in just a minute, okay? Square the front, put it in the front. Square the back, put it in the back. Stick them together, multiply them together, and put it in the middle. Square the front, put it in the front. Square the back, put it in the back. Multiply them together, put it in the middle. The last sign's always plus. All right, so I had my students say that over and over again. Square the front, put it in the front. Square the back, put it in the back. Stick them together, put it in the middle. The last sign's always plus. Square the front, put it in the front. Square the back, put it in the back. Stick them together, put it in the middle. The last sign's always plus. There's only one minus sign, and it's determined by the sign you're working with. So since this is a minus, this one, the minus sign's gotta go here, that makes that a plus. If that had been x cubed plus c cubed, it would have been a plus and then a minus, okay? So when you see difference of cubes, that's how you factor. And this is over x minus c, and that's beautiful because now it cancels. By the way, up until this moment, every time I try to fill in c for x, I get 0 over 0, it's undefined. Every single time, until right now. Right now I'm filling out the problem, and now I can finally find the limit, okay? So I'm not getting 0 over 0 anymore, which is, 0 over 0 on a limit means keep looking. It means there probably is one out there, okay? Not always, but probably. All right, now I'm gonna fill in c everywhere there's an x. So that's gonna give me c squared. What happens if I have c times c? C squared equals 12. 3c squared equals 12.
It was on a different slide.
Okay.
Yeah, there.
So this is equal to 12. 3c squared is equal to 12. That gives me c squared is cute little 4. So c is plus or minus 2. And c's and x's at this point can be interchanged, so that happens when x is 2. Okay, because x and c just slammed into each other. Do y'all see what I mean? Okay. So now I know I've got the point 2 comma something. All right, now how do I find the rest of the point? Sub it into which one? The x cubed graph. Okay, remember it's going to be parallel to some line off somewhere else. I've got to be on the x cubed graph, so that's 2, 8, and negative 2, negative 8. Okay, if I go back up to this picture on this slide, you see that makes some sense. This one right here might be 2, 8, where it was parallel and negative 2, negative 8. Okay, I'm gonna, oh, I hadn't even written the equation of the tangent lines yet. All right, so now I'm ready. I always use y minus y equals m times x minus x. So here's my point. Boy, that looks ugly. All right, so I'm gonna have y minus y equals m times x minus x. That's one of them. The other one is y minus y equals m times x minus x. All right, so let me show that to you real quickly on the calculator. Now I'm hot again. Let's see. That makes no sense if anybody's all of a sudden listening to me. Thank goodness other people don't be mine. Somebody's just listening to a calculus class. I'm like, now I'm hot again. Okay, you do need to be good at a calculator, but I'll guide you through. Like half the test is non-calculator, about half the test is calculator, but you really need to understand that all without a calculator to even be any good at your calculator. I'll get to that later. Y equals x cubed. I'll teach you how to take derivatives on your calculator and all that. And so one of them was 2 times x minus 2, and then it was y minus 8, so I'm going to add 8 to the other side. Do you see how I'm just solving mine? And you can like FOIL it, multiply, distribute, and simplify it if you want to. I just really don't care. One thing I'll be teaching you is you don't want to do too much algebra, especially you don't want to do too much trivial algebra, because that's where we're going to make our mistakes. I'll make my mistakes on addition and on trivial algebra. And so once you've got an answer that's right, you can even leave it 8 over 4. If it's right, I got to count it. Okay? Emma?
Shouldn't it be 12?
Thank you.
12
Oh, I
minus
missed it
2?
all up here. Yeah, thank you. I put in 2. I was putting in my x coordinate. Thank you. The slope is 12 in both cases. So this would be positive 12. Y equals mx, y minus y equals m times x minus x. Thank you so much, Emma, because it wasn't going to work for me, so always interrupt me like that, okay? And sometimes I'm like, wait, because I'm on a roll. And don't wait on something like that, because I'll get lost in my work, so. Okay, thank you so much. All right, so I need to change this to 12. I can insert a 1. So I could come down here, and I don't know why I put it way down there. This one's x plus 2. Minus 8?
Yeah.
Wait, this one's plus 8.
No, plus 8.
Yeah, the other one's supposed to be.
Wait, it was y minus y. This was
No,
going to be
because it's the
minus.
same.
They're both
It's the
positive
same.
and
No, it's the same y value for
Yeah.
both of them. Oh wait, no, it's not. Never mind.
So this is what I'm doing. I'm on this really ugly one right here.
Oh,
The x plus 2 one's going to have a minus 8 when I solve for
Yeah.
y.
Yeah, it's cute.
wait. Yeah, yeah.
I don't know where this is on my screen. Okay, so now I'm going to go to, I'll just go to Zoom Standard and see what it looks like. We'll probably maybe need to, also let me put in the line they gave us, which was 12x plus 10.
Oh, yeah.
Thanks. If I solve it for y, is it
Yeah.
12x plus 10? Okay. And let me change my window. Or are we gonna see it? Do you see that? Oh, that should, something's wrong with my black line. Girls, look. Something's wrong with my black line. Oh, no, it's fine. The black line just cuts through the graph. So do you see, this is the line it was supposed to be parallel to, and those two are tangent lines? Okay, so we did all of that. All right, so let me go back to 46. Because that's what somebody originally asked for, I believe, right? 46? All right, so this is 46. Do I have until 11:40 today, 11:35?
25.
No, 40. Because community time ends at.
I have it in my paper.
It's 40. It's 40.
Right, all the way to 40 because it backs up to lunch?
Because it starts at 30.
I'll use everything. Okay. All right, so 2x squared minus 7x plus 3. So I have y equals 2x squared minus 7x plus 3. Is that right? All right, and we're doing it at a point C, comma, f of c. That means at any arbitrary point, like the slope changes. What's the only thing, it's kind of funny up until calculus, you've only found slopes of lines, okay? When everything really had slopes, well, a lot more interesting slopes than those lines had. The lines are the only thing that have a constant slope. So you have to get to this point to realize there's so many things that have slopes, but they're usually you're going to have a variable in it because it all depends on where you are. Okay? All right, so 2x squared minus 7x plus 3. I'm going to take the limit as x approaches c of f of x, 2x squared minus 7x plus 3 minus f of x, which is minus f of c. So now I'm going to fill in c, and I have 2c squared minus 7c plus 3 over x minus c as x approaches c. You better be writing that down. If you're not writing that down, you're not doing calculus, you're just doing geometry. Okay? Did y'all see what I mean? That's just y minus, you could be anywhere in the whole wide world. That makes it a derivative. Okay? And that's tempting not to write it down, but you don't want to lose anything. Okay? So you can write it down really ugly like I do. When I'm doing the alternate form of the derivative, when you see those words, f of x minus f of c over x minus c, or it could be f of x minus f of a over x minus a in a book or a worksheet, same thing. You're usually going to factor. You know how I factored in the last one, 47?
Yeah.
If you're doing this method, be aware of like some sort of factor by grouping, okay? So I'm going to rearrange this. I have 2x squared minus 2c squared. I'm going to get my squares together because I'm used to this method. Then I have minus 7x. Be careful, I have minus a negative, or plus 7c. Always be careful with your negatives. And don't my 3's cancel? All right, over x minus c. So you're usually going to get your cubes, your squares, and your linears, or whatever together when you're doing this method. And the f of x plus h minus f of x over h method, this usually doesn't come into play. It's just usually collapsed when you factor out in h. If that makes any sense. All right, so now I'm going to factor the front after I trip across the room. So I'm going to factor out a 2, and I'm going to move really fast. I would suggest you move really fast. I don't have time to explain and do everything in class, so hopefully you are crunching it at home. But wouldn't that leave me x squared minus c squared? So that's a difference of squares. X minus c, x plus c. Can y'all see what's red?
Yeah.
Okay. Minus 7, be careful with your minus signs. That'll leave me x minus c. So did y'all see I factored out a 2 and then fell into x
Yeah.
plus c, x minus c? Be careful with your negative 7. Redistribute in your mind. Make sure you have it right. Now, girls, up until this moment, if I turned everything in her that if x actually slammed into c, I would get 0 over 0, which means you don't know what the limit is yet. You've got to keep looking, okay? And still at this point, this would give me 0 over 0. But what can I factor out of the top?
X minus C.
And therefore, I can really just cancel it as long as they all have it. Are y'all okay with that?
Yeah.
I wouldn't be able to just cancel one of them, but as long I'm really mentally factoring that out and slicing through it. Okay,
Looking for extend page. Should let me extend the page. I can't see it probably because of the color of this.
all right, anyway, I'll write really small. So this is equal to the limit as x approaches c of 2 times x plus c minus 7. And now fill in x becomes c, and so you have 2 times c plus c minus 7. Do you see now you can finally successfully fill it in without getting 0 over 0. That'll give me 4c minus 7. And now I forgot what the question is. Was that it?
Yeah, that's it.
Really and truly, we would run around saying the slope is 4x minus 7 at this point. Okay? X and c just slammed into each other. So I just found the derivative. I really call it 4x minus 7. And some of you might, Mr. Walters is really good about our supposed fight with each other. If you had physics and we argue, about things, and I'm really right, he's really right, but I'm more right than he's right. I'm more calculate. He's doing what he's supposed to do in physics, but if you know the trick or you think that an integral is an antiderivative and things like that from physics is not going to be completely true for us, because we got to delve into it as mathematicians and see where it really comes from. If you know the trick, take a derivative. If you don't know the trick, don't look for it. I'll show it to you next class. But you'll be really mad if you don't know the trick after what I just did, because I can just double check my work. I'll look at the trick. But the trick doesn't always work, so you're not going to be super mad. Okay. Any questions on 46 and 47 before we go on? All right. Other questions? Specific questions?
Do you have extra problems or at least textbook pages to review these? To do more of them?
I usually do. It can give you links to AP problems or other problems. I might find some good ones on Delta Math. There's just, if you know this, you'll be more than ready. And I do have some worksheets I'm going to give you today on limits.
Okay.
So,
Yes, for me, out of these problems, it's more like the stuff we did last year that I just forgot to do, the first few questions.
Yeah, same for me. I kind of like the other stuff better. I hate this question. So but I got to give it to you. Hey girls, before I answer her specific question, and also Morgan, if you'll shoot me an email, give me more problems, I'll just remind me to do it, and I'll send it to everybody, and you can do with it what you want to. Okay. You've got to be aware of everything about your function as much as you can going into it. It's not later in the problem that you figure out the domain and the range. You're aware from the beginning what the domain of that thing is. Okay, you've got to see the big picture, and I'll be talking about that as I go. Morgan, do you have a specific one at the front you want me to do?
Not really. It's just for most of them, I had to use notes.
Yeah, because that's the purpose of summer work.
Yeah.
It's a smorgasbord of stuff that you learn in algebra and pre-cal that I expect you to be great at. Piecewise functions, trig functions, logarithms and exponents and things like that. I could pick one to talk about that I think is important. So let's look at number 11. All right, so number 11 is y equals ln x, just plain and simple. We'll get, if I see a logarithm or an exponent, I don't freak out. You should not be impressed by that since I've done it for so long, but the point is, you shouldn't either after a while in here. It shouldn't bother you. It's just like a square root or a cube. It's just another mess. All right, so a logarithm's asking for an exponent, all right? And this is base what? E. Good. This is base E. All right. This actually is just shorthand for the logarithm of x to the base 2.718 to the base E. It's a natural logarithm. All right. Logarithms usually have vertical asymptotes, and so this cannot be in the negatives, and it actually can't hit 0. There's no such thing as ln 0. You'd be saying e to what power gives me 0. And you can't take 2.718 to some power, and you can get close to 0. You can put it to a negative exponent and get close to 0. All right, so if I make an XY chart, I don't make XY charts for these, but it doesn't hurt to find a few points to get your bearings. I think a lot of you know ln 1 is 0. If you have 1 right here, e to the 0 is 1. So I have this point 1, 0. In fact, your calculator will graph it like that. It'll make it look kind of like a square root. So you can't trust your graphing screen. If I put in like some other numbers, like if I put in 1/3, and I have ln of 1/3 to the base e is equal to what exponent? So this is y equals ln x. E to what exponent gives me 1/3? I don't really even know, okay? But I know it's got to be a negative exponent. Do y'all see what I mean? Because it's 0.333. So e to some negative exponent. It's going to be like about like 1 over 2.7, 1 over e is similar to that. We can punch it in, but let's keep going. Now, if you put in your calculator ln 1/3, if I pull it up, it'll give me a negative exponent. So I don't know what it is. It'll be a negative something. But at 1/3, it'll be negative. The closer that I get to 0 as a limit, the closer I get to 0, the more negative that's going to have to go because these numbers are getting smaller. And so a logarithmic graph actually plummets down to negative infinity. So my domain is x is greater than 0. My range is all reals. By the way, some of you know Mr. Hill, and I don't use or know set theory. When I was grading, just because I did it, I mean, one class in college, but he loves it, and a lot of people do. But AP readers aren't going to probably know it either. Like when I've read the past couple of years for AP exams, and somebody was using some sort of upside down slashy thing, and at our table of readers, we're like, what is this? The professor I was sitting next to from college taught set theory, and he bailed us out, but it wasn't my paper. But I had to do this. What's this mean? So, kind of follow my lead, and you'll be saying what they expect. If you say something else, they'll figure out what you're trying to say. They're not just going to count on it. But it makes somebody happy if they're just grading something they expect. Okay. So anyway, the range is all reals. It has a vertical asymptote at x equals 0. What else did it ask?
X and Y.
Oh, x-intercept is 1, 0, and it has no y-intercept.
Yeah.
Okay? But know that a logarithm graph typically looks that way. All sorts of other things can happen to it. Exponential graphs are inverses of that. An exponential graph typically looks like this, where instead of the 0.10, it has the 0.01, and it goes more like that. It has a horizontal asymptote, whereas the other one had a vertical asymptote. All the x's and y's has been switched. If you remember inverse functions, they're inverses of each other. Exponents undo logarithms, logarithms undo exponents. Okay? All right, I just picked one. I'll let you if you want.
Can we do like 21?
Yeah, can we do it?
21. Oh, yeah. Okay. I'm going to start off with this problem that I made up when Grace and I were working this morning. I brought it with me. I'm going to see This is not in your packet. It's just to make a point. I think that some of these two things were happening on these. Some people looked at this and they were so easy, they were hard. Some people looked at it and maybe didn't really know what to do. Maybe even thought you needed to multiply it all the way out or whatever. Okay, so look at this problem that is not in your packet. Grace and I just made this up this morning. And a lot of your misconceptions are our fault. Math teachers tend to teach all about quadratics with an equal sign, and then we go, but what about quadratics with an inequality? Girls, inequalities are night and day from inequalities. There is a world of difference in this and that. A world of difference. Would you agree? They don't even have anything in common at all, nor do you really work the problems. When you're on an inequality, you're doing something totally different. And it's tougher at first until you come up with a process, either graphically or algebraically, okay? Right now, I could do some guess and check, okay? That's gonna take me a long time. Do you realize that would be hard? I hope you know that. I might come up with one or two, but there's probably lots of things that work here. Another thing I could do is multiply through by x plus 2, but I don't want to do that. You might give me 2 reasons why I don't suggest multiplying through by x plus 2. I don't know what x is yet. And if it's if the x that I find makes my value negative, when I multiply by the other side of an inequality, I've got to change the symbol. Don't I? I don't know what x plus 2 is. I don't know if it's positive or negative. Another reason is I actually don't want to lose it. If I multiply it by 0, won't I lose something really important in my problem? Alright, so I'm going to get a common denominator. And you can just watch this. I'm going to get a common denominator because this is just too hard for me to deal with. So I'm going to go x minus 1 times x plus 2 minus 3 times x plus 1 over x plus 2 is less than or equal to 0. I'm going to keep all of this. It's still too hard for me to work with. Let me tell you why it's too hard for me to work with, okay? This is subtractive. This term is subtracting that term. What is a positive minus a positive? It depends, doesn't it? Okay? What is a positive plus a negative? It depends. But what doesn't depend is what's a positive times a positive. What's a positive divided by a negative? You see that multiplication and division are conclusive evidence of the sign. So in inequality, I'm looking for positives and negatives, okay? And so now I'm going to FOIL all of this out really fast and hope I do it right. This gives me x squared minus x minus 2 minus 3x minus 3 over x plus 2 that I want to keep. You really don't want to throw anything away. Remember that all year long. X squared minus 4x minus 5 over x plus 2 is less than or equal to 0.
Wait,
Now-
shouldn't the x squared plus x minus 2?
Oh darn, I really needed it to be minus. So thank you. So I made an algebra mistake. What if it's plus? That's okay. So,
Change the first problem.
that's why I thought I miraculously made one up. I'm going to come back to this problem either, I'll come back to that statement later. I've got to fix my problem. So thank you. This is plus x. Is that where I missed it?
Yeah.
So this is, I was so excited about how it worked out. This is minus 2x. But this is a great thing to happen. We got to do this in here. Okay? That one doesn't factor. Okay? I'll come back to that in just a minute. I'm watching the time. So let's just pause for a minute. What would we have done when I thought that I had x squared minus 4x minus 5 over x plus 2? Thank you for calling that out. If I had gotten that and made up the original problem correctly, this would be x times x, 5 times 1, minus and plus, over x plus 2 is less than or equal to 0. What I would do at this point, you see I have all multiplication and division finally? At that moment, I have factors, okay? I want to see where it's positive and negative, so I'm going to rule out where it's 0 and figure everything else out. So I'm going to do a number line. We'll do this a lot. It may not even have an inequality in it, but you might want to know where your velocity is negative to tell me if something is falling or rising, okay? Moving right or left. And so if you want to know if something's positive or negative, even if it doesn't say less than or greater than, use a plus minus chart to organize your information. What makes this 0 is 5. This is a number line down here. What makes this 0 is negative 1. And this one's negative 2. I don't remember it turning out at all like this when Grace and I did it. Maybe it's not the problem we weren't. Because I don't remember negative 1 and negative 2. Do you, Grace? They weren't that close together.
I think one of it was positive.
It doesn't matter though, let's keep going. All right, so anyway, now this is where it is 0, and I'm going to pick any number back here before negative 2. All right, so let's see, Sophia Lee, give me a number before negative 2. Negative 5. All right, what's negative 5 minus 5 is a negative. Negative 5 plus 1 is a negative. Negative 5 plus 2 is a negative. What's a negative times a negative divided by a negative?
Negative.
It's a negative. So back here, whatever she picked is going to be negative. Okay? A number between negative 2 and negative 1, like negative 1.5. Okay? Inconvenient, but I can do it. Negative 1.5 minus 5 is negative. Negative 1.5 plus 1 is negative. What about negative 1.5 plus 2?
Positive.
Positive. Between here, I think most of us would pick 0, but we could pick a bunch of different things. 0 minus 5 is negative. This one's positive, and this one's positive. That would be a what? Negative. By the way, don't assume that they're going to alternate. They don't all alternate. After 5, like 6, is all clicks to positive. That means I even know this graph is negative, positive, negative, positive. Do y'all see what I mean? Okay, so that's really what's happening there. I know all of my zeros, and I know what it's doing. And if I wanted to answer where it was less than or equal to 0, I would say from negative infinity to negative 2, and from negative 1 to 5. Sorry, this was not on your packet, but it should help you understand some of my answers. Notice I did not include the negative 2, even though it said less than or equal to. Why did I not include the negative 2? I've been aware of the domain from the beginning of the problem. Yeah. I've been aware of the domain from the beginning of the problem. I've known the whole time negative 2 can't be part of this. Okay? All right, now we'll end there, but let me go back to this one that I'm sorry I messed that up. Hey girls, everybody hold still for just a second. I'm gonna let you go before it's 11:41. Okay? That one, I would actually have to put the quadratic in my calculator and find the zeros. So you see, I could easily see where a quadratic is positive, negative, and positive, and then combine it with this factor. So that's why you need a calculator. Everything's not going to factor. Okay? All right, pick up a packet from me on the way out the door. The part of the packet that I post, don't, girls, listen, don't do it all. Do the part of the packet that I post and bring it with you to class and study, come by and get help, email me with questions. So you're also studying for your test and stuff. But this is not other stuff. This is just limits, okay? Please check assignment tab. up in about 10 minutes and see what assignment I'm doing. Is it 11:41?
You're getting it